Hi, it's Bentley's mom. This is the homework for chapter 11, lesson 3. We're going to do the independent numbers 2 and 3, and the hot problems 7, 9, and 10. Okay, so this is number 2 for the independent. It says texts per day, and they're written this way. The first thing you have to do is put the data in order. So, Bentley, what's the first one?
12,
12,
19,
19,
24,
24,
26,
26,
31,
31,
38,
38,
53.
53. Okay. So the first thing you need to do is put the data in order. Then it says find the median, first and third quartiles, and an interquartile range. So the median, it's not asking for outliers. We don't have to do that. We just need to do the first quartile, Q1, and Q3. So median, Q1, Q3, and interquartile range. Okay. So to find the median, take your fingers, 1, 2, 3, 1, 2, 3, and the median, or the middle, which cuts the data in half, is 26. Okay, then you take the lower 50% of your data to find quartile 1 and find the median again. So you can ignore the actual median, and from here, you go here, and that's going to be 19. Now, if you block this off and there's an even number and there's a tie, you find, just like the regular median, you would, if there's a tie between two, you find the mean between those, you add them up and divide by 2. So you go over here for quartile 3, and okay, you can kind of block that off, and this one works out perfectly. It's 38. Again, if there's a tie, you just find the mean between the two that tie. Okay, and then the last one is the interquartile range. You take Q3 minus Q1. So 38 minus 19 gives us 19. Okay, and that's problem 2. All right, now let's do number 3 on independent practice. Number 3 says the daily attendance at the water park is 346, 250, 433, 369, 422, and 298. Okay, Bentley, help me put this in order.
250.
250's first, so right here. Okay. Then
298.
good, 298. Okay, then
346.
346. Then
369.
good.
427.
I think that's 422. Yeah, sorry, bad handwriting. It's 422
And then 433.
and 433. Okay, so we got all of our data. Okay, now we're going to find the median. Okay, so 1, 2, 3, 1, 2, 3. So there's a tie. So what do we do when there's a tie? We add them up and then divide by 2. Right? So 346 plus
is
369
350.
is 715 divided by 2. We get 357.5,
Yep.
and that's our median. That's the first part. Now we have to find, so our median is actually 357.5. That's our median. Okay. Then we need to find quartile 1. Okay, so we're kind of going to not look at our median, but here's the line right here. Okay, so then we're going to find the median of the lower half, which is 298. And then we're going to find the median, if you will, of the upper half, which would be 422. Okay, so there's quartile 1 and quartile 2, and then quartile 3, and then the last one is the interquartile range, IQR. We're going to take Q3, which is 422, and subtract out 298, and I believe you get 120, 422 minus 298, and you get 124. Okay, and that's it. And then we're gonna do, oh wait, don't stop the video yet. Because we're gonna do the hot problems.
Oh, that was close.
Did you stop it?
No.
Okay. So the hot problems, let's start with number 7. Actually, there's a stem and leaf plot. I just want to show you real quick at the top. It's problem number 6. And I just want to make sure you guys know, I'm going to do that really quick, just how to write the data. On a double stem and leaf, if it looks like this, if it says 5, 3, 1, 0, and then 2, and then 5, 7, 9, 9. Okay, so up here it says Minneapolis, and here it says Columbus. Okay, and then there's more information. I just want to make sure you know how to read it. This is the stem in the middle, and these are the leaves. So this is like 2 sets of 2 completely separate data. So for Minneapolis here, when you list the data, it would be 20, 21, 23, and 25. So you'd list it like this, 20, 21, 23, and 25, and then you'd keep going. It'd be 34, 36, etc. And then it looks like 34, 36, and then 43. Okay, that's the Minneapolis data set. So Bentley, what would the Columbus data set?
I don't know.
Like, how would you read this? This is the stem. This data would be 20, 25 would be the first number. What's the second number?
27.
27, good.
Oh,
And then
29.
29,
29.
and then 29. That's how you read a stem and leaf. This is just a weird chart. So when there's a double stem and leaf, this is always the first number, and the leaves are always the second number. So you read this. This is another way of writing 20, 21, 23, and 25 for this one. And for Columbus, this is another way of writing 25, 27, 29, and 29. I would take it out of the stem and leaf and write it this way, and then you can do the math on it. But it's confusing kind of trying to read it off a stem and leaf. Okay, did that make a little bit of sense? Okay, so then number 7, the hot problem. It says find the error. Hiroshi was finding the measures of variation of the following data set. So he has 89, 93, 99, 110, 128, 134, 144, 152, and 159. So there's a data set. It looks like it's in order to me. Yep, it's in order already, so that's nice. So it says he found the median. So let's find the median, then we'll compare what we're doing to what he did. So 1, 2, 3, 4, 1, 2, 3, 4. Looks like the median is 128 because there's 4 numbers on this side, 4 numbers on that. So the median's 128. What he wrote was 128, so we did that part right. And then the first quartile, or quartile 1, okay, that's our median, so we're going to block that out. Now here, notice there's 4 numbers. So there's a tie between 93 and 99. So we have to find the number between 93 and 99.
96.
Okay, so it's 96. Okay, but if you don't know that, you have to do 93 plus 99, get that number, and then divide it by 2. And sometimes there's really big numbers with decimals and stuff, and you do need to use a calculator. But the number in between that is 96. So that's quartile 1. Okay, and quartile 3 is these 2 tie. So Bentley, what's the number between 144 and 152?
148.
And if you don't know, you add them up.
148.
And you get 296, and you divide that by 2,
148.
and it's 1.
I've told you.
What did you say? 148? So let's see. Because 148 is, if you add 4 to 144, and you subtract 4 from 152, that gives you 148. And again, if you don't know if the numbers are too difficult, you would add those up and divide by 2. Find the mean of those. So let's see what he got. First quartile, he got 99. So he actually used one of these numbers. So when you're taking the median, anytime there's a tie, you don't just pick a number. You have to find the mean between the 2 numbers that tie. And so he didn't do that. He just picked one of the numbers there. You can't do that. And then he also said the third quartile was 144. He did the same thing here. So again, when there's a tie, anytime you're finding the median or one of the quartiles, you have to add them up and divide by 2, or find the mean between those two numbers. And then he said the interquartile range, well, if you got these wrong, then the range is going to be wrong because you subtract those two. And then the other range, you would just do 159 minus 89 for the regular range. Okay, so yeah, he just didn't take the mean of the two numbers that tied. And then, okay, number 9, that was 7. Okay, then number 9, for the hot problems, it says, how is finding the first and third quartiles similar to finding the median? Well, because remember you find the median first. So when you find the first quartile, you're not really finding the median because the median's this, but you're really finding the median of the lower half of the data. And that's why it's the same. It's very similar because you're cutting the lower half of the data in half. And that's the same what you did to find the median. So the median, you take the entire data and you cut it in half. And then for the quartiles, you're cutting it in half again. And that's essentially the same process as finding the median. So that's number 9. And number 10, it says explain why the median is not affected by very low or very high values in the data, which are also can be outliers. But if you're going like this from both sides and you're getting into the center, aren't the really low scores not a part of what the median is and the really high scores? Because you're going away from the really low and high scores and you're finding the number right smack in the middle. So the number right in the middle, the numbers way out here and way out here don't affect the median because you're going towards the middle of the data. And they don't get used at all in whatever number this is. They just kind of get thrown out as you move towards the median. Okay, and that's it. Have a great day.